operations with square roots. You've got a little organizer here. We're going to do one example of each because you should know this. This is from Algebra 1. That might not be Algebra 1, I can't remember, but that's definitely Algebra 2. So the first thing you need to recall, and if there's any room at all, or go to the back, you need... I'll just write over this. I'll show it. Here's false. Okay, go to a blank area and let's refresh your memory on what a square root is. So, what is 1 squared? What's 2 squared? 4. What's 3 squared? 8. 3 squared. 2 squared. Y'all are counting. Sorry, y'all are counting instinctively. 3 squared is 9. Okay, what's the square root of 3? I'm sorry, what's the square? Now you got me messed up. What's the square root of 9? 3. What's the square root of 4? 2. What's the square root of 1? 1. Okay, square roots. I want you to list the first 15 perfect squares. And you get that by simply counting. 1 squared, write it. 2 squared, write it. 3 squared, write it. I want you to list the first 15. So you shouldn't be writing, the numbers 1, 4, 9, 16, and so on and so on. Go all the way up to 15 times 15. Okay, you should have the first 15 perfect squares. You should also now recall how to generate that list, right? You're just counting. That's all you're doing. You're counting in your head 1 squared, 2 squared, 3 squared, all the way up to 15 squared. Those numbers are going to help you in breaking down radicals, which will appear when we are solving quadratics, and you're breaking it down. If you're solving by square roots or solving by the quadratic formula and you have a radical that will break down, you are expected to break it down, okay? Enter the list of perfect squares, which will help you do that. Okay, so here's an example. We have the square root of 84, x to the 4th, y to the 9th, z, and we are asked to simplify it. So the first thing you need to do is simplify the number by itself. Don't look at that whole problem and panic and run. Just focus on the number itself. So what is 84? Is it perfect? No. So go to your list of perfect squares and find where 84 falls. 84 falls in between 81 and 100. And now you're going to start dividing by working your way down. Because obviously no number higher than it will go into it, correct? So you're going to start dividing. 81 won't go. You're looking for the first one that will go nicely. So 81's not going to go. 64 won't go. And you know this because it's divided into 84. There's no way. So keep dividing, and what do you find works? Do what? I don't think 16 works. It's 4. You're thinking of 80. 16. We're going to 80. 4 goes how many times? Okay. You are going to rewrite the 84 as the square root of 4 times the square root of 21. Always list your perfect one first because it's going to keep going. The perfect one's going to keep going. The one that came from the list will now square root. But I'm going to keep going with, we can write this here and then we can come back to the letters. So what's the square root of 4? 2. And then this will come down. I'm going to leave some space. Right? Or you can leave it right there next to it and then you just shove them together. They'll probably prefer that. Multiple ways to do this. So the number's done. Now I've got to do the letters. So I've got the square root of x to the 4th, the square root of y to the 9th, and then the square root of z. All I'm doing here is putting a square root over each individual letter, and I'm just spacing it out, okay? I haven't changed anything. That is still, if you shove them all back together, multiplying together, that's the exact same expression. I'm just trying to create room where I can work, okay? How do you take the square root of variables with their exponents? Okay, make a note. Exponent. There's 2 cases. Case 1 is if it's even. If it's even, you just divide by 2. That's it. That's how you take the square root of it. You divide it by 2, and it will come out because it's perfect. It'll come out of the radical to the front. If it's odd, not trick, but thinking question. How far away is every odd number from being an even number? 1. So if the exponent's odd, I want you, and I don't have a lot of room here, I want you to think about saying to yourself, okay, so what's the even number? The closest even number would be x squared, and that leaves 1 behind, right? That one you'll be able to take the square root of, and that one will just stay under. So if it's odd, you still can divide it by 2, but there will be a variable left under the radical. Okay? Does that make sense? You can still take the exponent. Look, 3 divided by 2. I can still do this. I get 1.5. Okay, so that means that I'm going to pull out an x to the first power, which would come from this. And then this means there's going to be 1 left under the radical every time. I'll show you some more examples. If you had x to the 7th divided by 2, okay, so that's what? 3.5. Yes? So this would become x to the 3rd with the 1 left over. There's my 3. Now don't put a half there, but the half means there's 1 left behind under the radical. Okay? Let me show you another one. Because repetition will help. X to the 9th. Okay, divided by 2. That's 5.5. Not 5.5. 4.5. Right? Okay, so that means pull an x to the 4th to the front, and then there's 1 left. Because when you take the square root of variables, write it in expanded form. That would be x. That 9? you're saying what times what would give me x to the 9th. So because it's an odd number, you can't cut it down the middle, and that's why. So basically 1, 2, 3, 4, it's odd. So now you can see, oh, it's x to the 4th times x to the 4th, but then you do have the one more left in there. That's the visual behind it. When you're square rooting variables, you just divide the exponent by 2. If it's a nice, pretty number, that's because it was even, and it's going to come out to the front. If it's an odd number, it's going to be something and a half, and the half means you better write a letter still under the radical, because that's the one left over from where it didn't split nicely.
I think what she was asking was because 9's a perfect square, so she was asking why couldn't you just
This is why, because that 9 is not translating to 3 times 3. It's coming from x to the 4th times x to the 4th times another x. That's why you can't take the square root of that way. The rule is different when you have exponents. So we're going to say divide by 2 and leave, put in a comma, leave the square root of x to the 1st underneath. You still divide by 2, you'll write the one that comes out, but then you will have one left behind. Okay? So right here, what's the square root of, put multiplication between all these. What's the square root of x to the 4th? It's x squared, right? Because 4 divided by 2 is 2, which means it was nice and pretty, which means the radical is gone, it came out. What's the square root of this? 4.5. So 4 comes out, the half means there's one left. Does that make sense? That's to the 1st power, which means there's nothing to do. Now, you have to be careful when you're writing this, because now you can see what needs to go together. If it's out of a radical, it comes to the front. If it's under a radical, it stays under the radical. So to the front, I have 2x squared y to the 4th. Under the radical, I've got 21yz. Good. All right. What if you're multiplying radicals? Remember with rationals, don't confuse these words. Rationals were fractions, radicals are square roots, right? Or cube roots or fourth roots. When you're multiplying and dividing rationals, you can do it every day, all day. When you're adding and subtracting them, you have to have what? Common denominator. Okay, the same concept is true with radicals. You can multiply and you can divide. I'll show you how to divide though. But you can multiply and divide all day long. When you are adding and subtracting, they have to have the same number under the radical. The whole thing has to match. It's like a last name. So you can't add and subtract until they match. Okay? So that's why this right here is saying, hey, if you have some type of root times another root, as long as the type of root that you're finding matches, you can show them together and write it under one radical. So like right here, this is the square root of 15 times the square root of 3. So that would be the square root of 15 times 3, which is 45. Then, of course, what perfect square goes into 45? 9 goes how many times? 5 times. So rewrite this as square root of 9 times square root of 5. And what is the square root of 9? 3. I'm going to show you the dividing, and then I will post an IXL for you to practice this. Get rid of the okay, so you see this right here? This is rationalizing, which is the equivalent of dividing. You're getting rid of the square root in the bottom. There's 2 rules in math. Can't have what in the bottom? Can't have a 0. You also are technically not supposed to have a radical in the bottom. So what's the problem here? What is the radical in the bottom? Square root of 3. So the only way to get rid of the square root of 3 is to multiply by the square root of 3, because then you're going to generate a perfect square which will evaluate. So just like when you were finding the LCD, you multiply by a fancy 1, you're going to multiply this by a fancy 1 that comes from the issue that was in the bottom. When I say the issue, the complication. Just multiply straight across. What is the square root of 9? 3. So see right here? This was by design. This is now perfect, which was the goal, because now that's going to be 5 times 3, which is what? 15. And then technically, what would you do? You would simplify that. If you got here, I would be happy, but y'all should be leveled up to get here. I'll post an IXL for you to practice, and obviously, since we didn't finish this, the test won't be tomorrow, but you need to be prepared to take it as soon as I say it's the next day. Okay? Yeah. Yeah, if y'all need help, come to my flex. And that's the same one we're doing.
But they're not doing what we're doing. Like, I tried to use my textbook to, like, draw on some bits.
Yeah.
Nothing on textbook.
What shows that? Send me a picture of your notes next time. I'm curious.
Everything she has class at 8. Because I live right next to them.
Yeah.
So she'll probably